Welcome. This is our last laser for this Woven Skies exhibition. So it's so wonderful to see everybody's here, to see the culmination with these incredible, amazing speakers, two of whom were with us in Chaco 2 days ago, where we presented at a Star Party, which was incredible. So if you don't know me, I'm Andrea Coley. I'm a professor of art, associate professor of computer science at UNM, and I'm also a member of SciArt Santa Fe. We promote excellence in art science in that intersection that we call SciArt. And one way we do that is by hosting what's called lasers, Leonardo Art Science Evening Rendezvous. They happen around the world, started by the Leonardo Society for Art and Technology. So we're very proud to be the hosts of the New Mexico Lasers. I want to thank our great partners, Santa Fe Art Institute, of course, UNM, the National Endowment for the Arts, New Mexico Arts, and individual donors like you who want to see art and science thrive. Like many nonprofits these days, we are very dependent on that. So if you are not already subscribed, you can subscribe to our monthly newsletter at sciartsantafe.org, and there's some of these floating around that has the URL on it. You can just go there, there's a subscription line. Subscribe, get our monthly newsletter. Also, some of you have been interested in the work and possibly even purchasing the work by these incredible New Mexico artists who we found through an open call. There's a paper on that pedestal there that has a copy of all the wall text. So you can take that with you. Artist information is there. You contact the artist directly if you're interested in any of the work or any of their other work, which is amazing. Also, I have two things before I get started. The wonderful Frances Whitehead, a member of our community here in the Orange, incredible artist, has created a project called The Tank, part of her project called Casa Agua, and there is going to be a grand opening of that on Saturday, June 21st. There are flyers for that here, and you'll see it on our newsletter if you are subscribed to our newsletter. It should be an incredible experience.
Come on down.
And talk to Frances, because she'll tell you all about it.
Summer solstice, prickly pear mocktails.
Yes, nice. That fits so well with Woven Skies. So I am going to, before I introduce our wonderful speakers, I'm just going to take a moment to do a land acknowledgement. And this is from the Santa Fe Art Institute research. So the land we are on has a very long history. Oke, the original Tewa name for Santa Fe, which means white shell water place, is located on unceded territorial lands of the Tewa and Tanos people. We honor these people, past, present, and future, as well as the many other indigenous peoples who inhabited, held sacred, and stewarded this land and continue to do so today. Yes, please silence your cell phones. Thank you. We have three speakers today. They're going to speak for about 15 minutes each, and then hopefully we'll have a lot of dialogue and Q&A. There are seats, guys, and we can bring more chairs out. I'll bring more chairs out in a second. I'll first introduce our speakers. So we're going to start with Dr. Julia Bluebird. She's an astrophysicist, Lakota educator, and STEM arts collaborator, and she will share how she brings youth leaders into contact with the cosmic web and how galaxies grow and evolve within this underlying structure of the universe, which was so incredible to see her slides 2 days ago and then go out to Chaco and see the sky. It was like, so that woven image was right there in my eyes. It was amazing. She will share indigenous perspectives discussing how traditional knowledge aligns with and enhances modern astrophysics. Then we're going to go straight through to Agnes Chavez, who will share the amazing Space Messengers project, an immersive and interactive installation that invites participants to explore the universe through the lens of particle physics, astrophysics, cultural cosmologies and futures thinking. And both Julia and Agnes have worked together, so they'll talk a little bit about that as well. And then the wonderful Nancy Conrad will kind of be a respondent and a discussant. A former teacher, Nancy Conrad, has become a recognized leader in transformative education and named one of the top 100 leaders in STEM education, serving as a featured speaker at national and international conferences. Her presentations include TED, MIT, and the Global Diversity Leadership Conference at Harvard. Nancy has also testified before the U.S. House of Representatives Committee on Science, Space, and Technology, detailing how the Conrad Foundation exemplifies the use of partnership to improve STEM education. She is the wife of late astronaut Peter Conrad, who during the Apollo 12 mission became the third man to walk on the moon. So please join me in welcoming our speakers.
Thank you so much. It's great to see all your faces here. And I would like to encourage everyone to look up. Julia Bluebird Amachiapi. I am from Pine Ridge, South Dakota. I'm Oglala Lakota, and I currently live in Socorro, New Mexico. I'm going to show you a little bit of my research. This is an image of a galaxy taken 5 billion years back in time. And the image on the left is a brand new JWST, and the image on the right, the underlying black and white, is a Hubble Space Telescope image, and the purple contours on top is my radio image that I make of the gas in the galaxies. So galaxies are made of stars and gas, and the purple contours are the gas that I image with the radio telescope outside of Socorro. So this is just a 15-minute talk, so I'm just going to tell you a little bit about my story, my roots, my surroundings here in New Mexico. I'm going to show you some pictures that I made of galaxies. We'll talk about some of the art that the students do, and then I always give the audience homework at the end of my talks. So my story, I'm both an electrical engineer and an astrophysicist. I spent many years working as an engineer at NASA, and I worked on communication systems for the surface of the moon, and I also worked on the Orion spacecraft, which I'll show you some images of that as well. Then I switched fields, and I became a scientist and astrophysicist, and I was surprised to learn how different those two things are. Initially I thought it's all math and it's all the same things, but they're two very different things. And so in my everyday life, I make pretty pictures of galaxies for a living. So as an engineer, I built the spacecraft for NASA, the Orion spacecraft. I worked on the design and development of the communication system. And so the picture on the right is me in the zero gravity plane. I'm actually standing on the side of the plane, and you can see my hair is a little bit crazy there. And the image on the left is Orion, launched a couple years ago and actually orbited around the moon, and this is a picture that it took of itself. And so it was pretty spectacular to see that happen. I'm also an astronomer, and I make pictures of galaxies. This is a picture of me in my backyard in Socorro, and one of the things I love about New Mexico, you have incredible dark skies here, and they're dark in a way I've never seen before, so whoever lives here is really lucky to be able to look at the night sky like you can here. And so as I mentioned before, I'm from South Dakota. I'm Oglala Lakota Sioux, and I'm from Pine Ridge, and so my home is really Pine Ridge, the reservation, and the Black Hills. And I love to camp, so it's my favorite place to camp. If you have never been there, it's an amazing place to do that. But here's a picture of it. It's a really beautiful area. And so the Lakota, we have our own constellations, and we're very tied to the stars, and we relate the stars directly to the land. And we have our ceremonies tied to the stars and the times of year. So however the sun is moving through the constellation, that dictates like where we are on our land and what ceremonies we perform. So our whole life is really tied to the stars, and it's a pretty amazing thing. This constellation on here, we call it the sacred hoop. And this is another picture of it. It's actually made of these stars that you see in pink here, and these are the brightest stars in the sky. And so if you go out in your backyard, you will be able to see this. And the best time of year to see this is in the fall, straight ahead. And the Pleiades is something you can see with your naked eye. That's part of the sacred hoop. And so these are things that are it's easy to make this out in the sky. So I wanted to say a little bit about the surroundings here in New Mexico. It's an amazing place to be an astronomer, both with Western science and also the ancient indigenous astronomy that is here. And we were just at Chaco a couple of days ago, and it's so amazing that these sites still reflect the wonder of the night sky. And it's amazing to be able to pair that with modern technology. New Mexico is such an amazing place to be an astronomer. We have the Very Large Array, just west of Sapporo, and this is the most productive ground-based telescope in the history of astronomy. And I don't know if people really realize that you have that here in your backyard. Also, there's another observatory at Apache Point, and there was a survey called the Sloan Digital Sky Survey, and I'll show you some images in the next couple of slides. And this is one of the most cited astronomical surveys that has ever existed. And so you have all of this happening here in New Mexico. So I just wanted to show you some pictures of my research and some of the motivation that I have. So I study how galaxies assemble, grow, and evolve. And we don't know that much about it. And I was surprised to hear that when I entered the field. But like I said before, galaxies, simply put, are made of stars and gas. The stars are more in the center part, and the hydrogen gas is what I study. It's much more extended outside of the center, and you can see the gas with radio telescopes. And so I try to learn how galaxies get their gas, and I also study how the galaxies evolve in relation to the large-scale structure of the universe. We also call that the cosmic web. And I'll tell you a little bit about that. So this is one of the students that I work with. This is an image here of two dwarf galaxies. They're separated by 67 kiloparsec, and what that means, if you could fit two Milky Way galaxies in between these two, but these two galaxies are interacting, and they're about 79 million light years away. And so I'm going to show you a VR video of what our data looks like. And so here are the two dwarf galaxies. And this is our actual data. We have three-dimensional image cubes that we look through. And so these galaxies are relatively nearby. And so the data looks very clean. And so we're looking at a side view of the galaxies now. And so this just gives you an idea of what our data looks like. And I'll show you another image. So this is a galaxy that's much further away. And on the left is a JWST image. And on the right are the purple contours of the gas that I image of the galaxies. And so this galaxy goes back 3 billion years back in time. And so we're seeing it as it existed then. And so this galaxy is much further away, and so you can see in this data, the data is much more noisy. And we're looking at it from the side view now. And in just one second, you'll see the rest of the data pop up. And that's what the data looks like. There's a lot of artifacts that we have to try to remove, radio frequency interference and things like that. So you can see how hard it is to see. This is one of our easy galaxies to find, and so you can see how hard it is for us to find these. So I also wanted to talk a little bit about the cosmic web. and this is the largest structure in the universe. And so if you could zoom out and just be able to see the universe, this is what it looks like. It looks like a web. There's areas that are that are very dense, and then there are areas that are they're much less dense. And there's little pockets that look like bubbles, and so we call it large-scale structure, and kind of a slang name for it is the cosmic web. And this is actually a simulation. And this is an actual picture of the cosmic web. And so each little black dot on here is a galaxy. And this data was taken from at the Apache Point Observatory, as I pointed out before. And so these purple lines are the filaments in the cosmic web. And so, and the pink squares are my galaxies that I observed with a very large array. And so all of this data has been taken by telescopes in New Mexico. And this was my very first published paper. I wanted to say a little bit about artificial intelligence. We astronomers have been using AI for many, many years. We call it machine learning, and we use it. We have huge data sets. We have a lot of things to sort through, and so we've always used machine learning and artificial intelligence to help us look at our data sets and analyze everything. And so it's a very powerful tool for us to use. This is really fun. This is SciArt's lab, and you'll hear more about it from the founder in the next presentation. But I've done several events with Agnes and her students, and this is one of the coolest things I've ever seen. It merges real life science with the cutting edge technology and beautiful art. And there's also every kind of ethics statement woven into it. And so it's a huge leadership training experience for all these students. And it's all of this together, and it's so cool. It's so the future and so well done. And so I'll let you go into a lot of the details of that. And as I promised, I like to give homework. And I wanted to show Andromeda. This is our closest major galaxy to us. It's 2 million light years away. And you can see this galaxy with your naked eye, especially here in New Mexico. And this is kind of the scale of what it looks like. When you look at it, it'll be a little bit less bright. It'll look a little bit like a fuzzy patch in the sky, but that's kind of the scale of what you will be able to see it. But it amazes me knowing what I know about the universe and galaxies when I can sit on my deck in New Mexico and see this with my own eyes. I can look at a galaxy. So I encourage everyone to go and do that. And so I just wanted to just say everything is connected in our woman skies. And being Indigenous, our culture, the way we live our lives, we live it, that we're all connected. All of us are relatives, and we're all connected to everything. And that's actually what we learn in physics, but we learn the mathematical part of that. And so those two things really go together very well. And I always tell native students, you're natural physicists already, just by the way that we're raised and what we believe about the world. And so everything's connected. And just want to remind everyone to look up.
Okay, for those of you that were at Chaco, I did something a little different. So this is recorded. The last one in Chaco is recorded. I made that one more focused on education, the education program, and this one more focused on the art and tech. So if you want to see the education one, you can go first. I'm going to start with a video. Can you hear that? Where's that noise? What can you see? Can you hear it? Out there in the dark. long time. So I'm a new media artist, and some of you know that I'm the founder of SciArt Lab, which is a nonprofit organization based in Taos, New Mexico. SciArt Lab is a SciArt production studio and a STEAM youth leadership program. And I'm going to share with you in this presentation some of the examples of our work and how we're integrating AI and XR into our creative process. That video was particularly from 2023 when we were exploring VR. So what we do is we connect New Mexico youth with world-class artists, scientists like Julia, cultural specialists, and innovators who are leaders in their fields. Our mission is to inspire students by working with them to create immersive art installations to expand their identities as planetary citizens and to deepen their artistic, scientific, and humanistic literacy. These installations travel to art and science festivals in New Mexico and around the world, with students serving as ambassadors, sharing their insights with the public. I often get asked why I, as an artist, focus on the study of the universe and space through the lens of particle physics and astrophysics. And the answer is very similar to Julia's experience. I share this same curiosity to understand these big questions of humanity explored through fundamental science. Where do we come from? What is the universe made of? Where are we going? How everything's connected? Just through the artistic lens. And we are in what's called the second space age, and it's becoming more important for all of us to develop basic science and space literacy and to start to expand our identities as planetary citizens. So we call what we do space humanism. It's not like a widely established or formally defined term like in the academic or scientific literature, but it captures our perspective and it appears in emerging discourse, especially in speculative, philosophical SciArt worlds. And it's a term that is gaining relevance, particularly as humanity explores the ethical, cultural, and existential implications of space exploration. I'm going to share some slides from our more recent work. We just installed at Fermilab, the particle physics laboratory in Chicago. I just completed as a 2024 Fermilab guest artist in collaboration with guest composer Misha Zubko, and also a team. We work as a team of artists, coders, scientists, and students. This mixed reality exhibition brings together quantum physics, neutrino science, sound resonance, and augmented reality to explore how invisible forces shape our universe. I'm going to play on the left this little clip. This is a generative art piece from high school student Feliciana Mitchell-Gonzalez, guided by her artist instructor Ian Harrison, visualizing the boot camp that she was part of with Julia, where she learned about the cosmic web. So this was her visual interpretation.
This piece is about galaxy filaments, and galaxy filaments is another word for the cosmic web. As you see, there's specific points, which are nodes, and they're connected by the strands. So if you kind of press on it, you can see that it separates a little bit, and it's kind of simulating how the web stretches and moves as things pass through it and pass by it. This code visualizes the cosmic web, which is the largest structures in the universe that kind of is the background of the universe, if that makes sense. It represents the distribution of galaxies in the universe, where they are arrayed in long, interconnected filaments separated by vast voids.
And then on the right is one of the 4 AR installations that visualizes a year of simulated neutrino event data, which was about 270,000 events, and I tried to print it. It was 5,000 pages long, so I did not print it. And it's a live generative animation that appears in 3-dimensional space looking through your phone. The other installation that is in that same exhibit is called Neutrino Cloud of Probabilities. It was first shown at the Los Alamos Science Fest as part of the Andrea's show that she did there. What was it called?
SciArt Santa Fe show.
Yeah. Well, he was there. And that's where you first got to see him. It is a year ago. Visitors were able to scan a QR code and point their phone at the sculpture, which features a single PMT photo multiplier tube. I'll play this little video here. And so the same PMT is used in neutrino detectors and simulates wave function collapse when they tap their screen on the mobile. And particles emerge from the PMT and strike the gallery wall, which is 24 feet, and transforms it into a glowing grid of small gray rectangles, which symbolize the 11,000 individual PMTs that line the walls of the Super Kamiokande detector in Japan, which is the most beautiful work of art that I've ever seen. And this other installation showing there is in collaboration with Misha Zupko, who is the Fermilab guest composer. And our team created an augmented reality visualization that responds in real time to the resonant tones of his sound experiment, which were these crystal glasses. And this one is a fully AR installation called Dune. Oscillating Flavors in Time is what it's called, and it was designed by Ian Harrison, who was actually a graduate of UNM and joined our team as soon as he graduated. Now he's the instructor and the artist, and he worked with the students Feliciana Mitchell, Mohammed Khan, and Zion Flores to create this. And it visualizes the path of neutrinos from Fermilab in Chicago to the new neutrino detector being built in South Dakota called DUNE, which actually is an acronym for Deep Underground Neutrino Experiment. Nothing to do with the movie. So all of this technology that we've been working all year to build, it's AR, XR combined technology, and this platform that allows us to do it. A lot of those prints you saw showed a lot of the code and all of the back end of it. Now we can use this to integrate these generative art into the installations using Eighth Wall, which is the platform we use for the AR, for the augmented reality. And we're going to be using it in our new Astro Tours that Julie is going to be part of, which launches July 12th at the Harvard Art Museum from 8:30 to 10. QR code if you want to know more about it. And lastly, I want to talk about Space Messengers. That's our flagship project. It's an immersive mixed reality installation that we started during COVID in 2020. It was invited to Ars Electronica Festival in Linz, Austria in 2023. And in this video, I'm going to show you our ambassadors explain to the participants how it works, so you get to hear directly from the students.
Space Messengers is an immersive mixed reality experience that combines international students from different countries. This is the 5th city that this project is being presented.
It's more international, it's really good.
We have workshops with different scientists and philosophers and artists that talk to us about the great questions of humanity.
A massive event like that could cause space-time itself to ripple.
And it all culminates in this art installation.
And there are 3 activities you can try here.
That one where you can talk to a real particle physicist.
It's carbon and nitrogen in the compound that makes it green.
Just to clarify, he's a real person. He's not AI.
Over here, it's the Space Messengers board.
Well, you've seen these messages popping up. So these are messages either from students, teachers, or visitors.
So if you want to leave your own message, you just have to scan that QR code, and the message will travel with us through the festival.
Here we have a movement sensor station, which captures your silhouette and then puts it against a database of videos.
Each of the little dots is a video.
When we look up and point our telescopes into space, the universe is sending us information.
And what you can see in this process, it's the VR section. There's 4 different worlds to explore, and each one of those worlds represents 1 year of this project.
So I think Space Messengers is such a nice project and works so good. It's all about giving skills to the students, preparing good citizens for the future, for an interplanetary, sustainable, universal future.
A huge part about being a futurist requires us to bring some of those futures to light. And often, as we look back through history, some of the most important ways to do that is all through artistic means of storytelling.
That is Raphael. He was 13 when he started with us, and he's 17 now, and he's amazing. He's in theater. All right, so this brings us to where we are now. So we are going to be taking space messengers to the next level thanks to a grant from the Patrick McGovern Foundation, which is asking us to integrate AI for social good. And so it's really wonderful to have the opportunity for this development. And we're going to be adding AI, and it's going to be integrated. It's going to be premiering on September 12th and 13th in Taos, New Mexico, for anybody that is close by in Taos. So what we're going to be doing is building a large language model that is also what is called an AI vertical agent, because it's trained specifically for this SciArt installation. This is our core team. We have quite a few people working on it. I have to be manipulating the phone and my script, and so excuse me for a little bit of delay there. So this new version of Space Messengers will include more space messages, of course, from communities around the world. Now the messages are going to be analyzed and categorized by our fine-tuned AI model. There's going to be interdisciplinary human connection between the messages that are going to be dynamically generated in real time. And that interactive silhouette that you saw now is going to allow participants to explore the messages through their bodies in space. These are the core categories that will be creating the clusters. We're training the LLM with science facts collected from our science partners and organizations. The short 40-second video clips you saw also appear in the projection video. I'm going to play one of Stephen Goldfarb. So this is the science that informs a lot of the workshops that the students are part of, and now we share it with the public.
Human beings, since the beginning of time, have a lot of really big questions. Where do we come from? What are we made out of? How do we measure what we can't see? This question is at the heart science. Well, there's different ways that we do that by exploring, building devices that allow us to see more. We also do it by what I call extrapolation, thinking about things. Based on what we've seen, what do we know? When we look out, what have we learned? Galileo, he came up with this idea of using glass to build a telescope and to look out into space. We also listen out. Recently, there's an experiment called the LIGO experiment and also the Virgo experiment. They can actually measure whether space-time itself has changed. When we look out at the light that comes from way far away, the further ones we look at are older, and so we have figured out exactly how our universe expanded over the course of time. I've come a long way.
That's Stephen. He's been with me since 2013 when I did my first residency at CERN. So he's amazing, and he's part of the team. I'm going to skip that one, go to the next one. So under the ethics and policy, we're training the LLM with documents and treaties that carry the ideals that we aim for in imagining a sustainable interplanetary future, such as the Outer Space Treaty of 1967, which a lot of people don't know about. I have a QR code there for those that are interested. Under nature, for example, we're adding the Universal Declaration of the Rights of Mother Earth. Here's some examples of some of the messages that come from students. The Universal Declaration from the Rights of Mother Earth, which I also have a QR code there. Here's some of the examples of like messages that we share from scientists and from people to inspire the messages. Okay, and that brings me to where we are right now. So we have now connected all our messages, our thousands of messages, from Firebase, where they exist in a stored database, to Touch Designer. So now we can actually manipulate each message in real time. So here you start to see the messages popping up. I like this one because it's one of my favorite, which talks about the intergenerational messaging that happens in this project. So this was a student that asked her grandmother for what she wished for the future, and she wrote, "My grandmother wishes for exquisite social equality, comfortable interplanetary travel, and she says she wishes she could go." So these are people from northern New Mexico that we were asked the question, and it's really wonderful to get those kinds of messages along with the science facts and so forth. So for those of you that, one more example, and here you can see some more messages from the people that participated, and this is not just the students, but also the audience when we share the installation. Here's some more. So if you'd like to give it a shot, you can hold up your phone and scan it, and you'll get a box. and then maybe you can save your URL, and then you can send your space message when you get inspired, and then you get to be part of it, or you just snap a picture and do it later. Thank you so much.
So thank you for all the great work you guys are doing. It's just superb and very exciting. And our work's a little different and very much the same. So I like to tell stories. And most people know that we went to the moon, and a lot of people don't believe it, but we went. And everybody knows what Neil Armstrong said when he landed on the moon. What did Neil say? One giant leap for mankind. Well, they were 4 miles from their landing site. Could have spoiled their whole day. And NASA decided that they would do a pinpoint landing on the moon. And you gotta think about that, people. There's nothing to navigate from. There's no buildings, no shadows, no nothing. They had sent a surveyor up to the lunar surface several years before the moon landings. And the surveyor took imagery of the lunar surface and sent those images back to a place where you've been, which is Johnson Space Center, where they made very sophisticated models of the moon out of paper mache. Of course, this is 1969. And so they decided that the perfect place for Pete's Apollo 12 vehicle to land was next to the surveyor. Oh my God, that was really hairy. So they do all this navigation and all this stuff. And Pete and his crewmate, Alan Bean, who was the first artist to land on the moon, they land, Pete goes down the ladder. His first words were, whoopee, because they had landed right smack next to that surveyor, which was a miracle of navigation. And then Pete was the smallest guy in the astronaut corps, so his first words were, well, it may have been a small one for Neil, but it was a big one for a little guy like me. His first words. What happened to Pete before he went to the moon is part of the foundation of the work that we do with the Conrad Challenge, which is a global competition for high school students, 13 to 18, from all over the world. You know, when these guys stood on the moon and they looked back at Earth, what did they see? A little blue and white marble in a black velvet sky, no borders, no boundaries, fragile. We really go to Earth, and it's all about, I mean, we go to the moon to save Earth, basically. And all the things that NASA does are really Earth science, because we gotta save this little thing that we call Earth, that we've got 8.5 billion people living on right now. So how might we think about that as an opportunity for collaboration? I don't know if you know this, but when we went to the moon, it was probably the most amazing business model of anything we've ever done. What was it? It was leadership, funding, government, industry, and academia all working together with one goal, and 400,000 people with the same mission. There's a great story, and I can tell stories all night, so just time me and tell me to get off the stage. So there was a very famous Italian journalist who went down to Johnson Space Center, which is the center of manned spaceflight, and she started talking to this guy, and she said, well, so what do you do here? He said, oh ma'am, I'm sending a man to the moon. So she starts interviewing him, and he knows everything. He knows every widget, he knows where everything is. He knows how the guys work together, he knows Deep Slate, and he knows all the lunar astronauts. And she's talking to him for like 2 hours. And finally she said to him, well, tell me your name and what is it that you do here? He said, ma'am, my name is Ralph, and I'm a janitor. So that's the culture that sent humans to the moon in 1969. And it wasn't easy, as you know. So I want to share with you Pete's story, because you'll find it, I think, quite extraordinary, and how that has led to the work that we do with the Conrad Challenge, the Conrad Foundation, and now master classes focused on water. It's our first mission. So, Pete was a kid who was in a very snooty school in Philadelphia, and he couldn't read or spell. What was wrong? Anybody know what was wrong with him? Huh? Dyslexia. They didn't know what it was, and they thought he was stupid. So he hated school, and he dug a tunnel under the school so he could show up for roll call. Remember, we used to raise our hands in roll call? And then he would go in the tunnel and jump on his Indian motorcycle to go to Paoli Airfield, where he could mow the lawn for flying time. Pretty soon they found out this was going on, and he was flunking everything. And they threw him out. And so his mom found this little school in upstate New York, and she took him there, and he soloed when he was 16 years old. You gotta think about that. I mean, most kids at 16 don't know how to tie their shoes, right? I love him, but it's a problem sometimes. So he gets to this school, and the headmaster sees something in Pete and takes him under his wing. Pete ended up learning how to learn and learning how to think. That's at the core of education as it could be, might be, and I think will be. Critical thinking skills. He ends up with a scholarship to Princeton. Now, could have just as easily been prison, but it was Princeton. And it was also compliments of the United States Navy. Gets to Princeton, it's their first year of aeronautical engineering. Perfect, likes to fly, doesn't have to read or spell, So he graduates as an aeronautical engineer, and now he owes the Navy a couple of years, and he's top gunning off of a carrier deck that happened to be the commanding officer was one of the original Blue Angels. Pete's having the time of his life when President Kennedy decided we were going to go to the moon. Yes, sir, like to fly, don't care where you go. Pete ended up with 4 flights in space. He flew Gemini 5, which established we could be there for 8 days. That was the return voyage, 240,000 miles from Earth. That's, and they didn't even get points for that. No frequent flyer or anything. Then he flew Gemini 11, which established rendezvous. That was how we were going to land and return back to Earth. Apollo 12, and I just shared with you the third man on the moon. And then he flew Skylab. It was our first space station. It was damaged at launch, hanging on a tether that was held onto by his 2 crewmates inside of a Saturn V rocket. The lab was damaged, and there was a solar array that had a copper strap across it, and it unfolded like an accordion, except it didn't unfold. So the whole lab was heating up, and that could have spoiled the whole mission. So Pete's hanging on a tether with a very sophisticated piece of equipment called a shepherd's crook, what they used to repair telephone poles with, and he's yanking on this thing, and it opens up, and he said, I thought I was going to be the first arrow ever launched in space. Well, it was all okay. They finished the mission. For that, he was awarded a Congressional Space Medal of Honor. Pete went on to work in the aerospace industry, and we talked about, and you mentioned this, Agnes, new space and the next generation of space. I don't know if you guys know this, but it was born right here at White Sands Missile Range with a single-stage orbit vehicle called the Delta Clipper Experimental that Pete Conrad and his team were flying out of Wismar. And it went up, went down, and it really opened the corridor to the commercialization and privatization of space. His idea was for us to go from California to Italy in 45 minutes flying in low Earth orbit. That'd be super cool. Well, everything was going along just great. He created a company that could monitor satellites on a multi-user basis instead of onesie-twosie. It was like a phone pole in space, a patented, brilliant idea where we could monitor multiple satellites all over the world, download the communications, send it to the company who launched this. You're nodding your head, you must know this stuff, yeah?
It's interesting.
You're a space nerd? Okay. So, all things were going really great, and then on July 8th, he went on a motorcycle ride with a bunch of guys that he'd always wanted to do, and he didn't come home. So I did a lot of work in patient safety, I still do. And then I wrote his biography. And then I created the Conrad Challenge to honor his legacy of education, innovation, and entrepreneurship. So we started with 20 kids in a hangar at Las Cruces. We're now in 83 countries and thousands of kids. We invite them to create commercially viable products to solve challenges in space, energy, cyber, health, and water. That competition is now under the wing of Space Center Houston, which is perfect. That's where Pete's lunar suit is. And the Conrad Foundation has new work streams. We're launching master classes with different topics. The first one will be on water. We will ask students to submit a 1-page or 1 minute or anything they want. Could be art, could be music, could be a blog, could be a podcast, could be a painting, and tell us what they think about water and what's going on the planet with respect to water. A big secret, don't tell anybody. We're gonna say that we're gonna let 30 kids into the master classes. We're gonna take all of them. And so we're gonna have world level speakers. It's all online, they don't have to go anywhere. They're gonna learn about topics that are really important to the sustainability of the planet. The one thing that we do two things that are quite rare. We take stuff to space, and we just took a memory disk, and it's gonna come back to Space Center Houston, and it's gonna reside right next to my husband's suit that he wore on the moon, which is pretty cool. And the other thing we do is we don't fund these kids. They're writing business plans, market studies, prototypes, and websites. And they pitch in real time in front of government, industry, and academia. We're basically growing the next generation of unicorns. But I don't want to fund them because that's going to teach failure. Even if we gave them a lot of money, they're going to fail. Their kids are 13 to 18 years old. Here's what happens. They become eligible for a patent, the ones that win, and the ones that become Pete Conrad Scholars, which is the top award. It's basically a ticket to any university or any school or any job you want to get, because at the other side is someone who knows you can GSD. All of our kids get a GSD. You know what a GSD is? So I don't have a PhD, but I have a GSD. I get stuff done. All these kids get stuff done. What's beautiful about this work is it's all on the internet. These kids work together across countries, cities, states, socioeconomics, genders. They don't care where you are. This is where education can start to become diplomacy, and maybe peace will break out. That's the big hope. So thank you for listening to my story. It's stories that you wouldn't hear otherwise, I'm sure. And thank you for the opportunity to share this story with you. And thank you for the great work you're doing. I mean, it's breathtaking. And when you look at all of the work that you do, and the planet, and the galaxies, and you look at us and we're just this little tiny, teeny, tiny speck in the universe, people, we gotta take care of this little blue and white thing. Thank you for your time.
So we wanted, especially since this is the last laser, to really have some time for a lot of discussion and Q&A. So we'd like to open it up to the panelists if you have questions for each other. Anybody want to?
I just have a question about, so I was just like, I've been dealing with that with my own practice in some ways as well, like thinking about like the use of AI and like the environmental impacts that AI has, like with water, with energy, and like greenhouse gases, and I was wondering how you navigate the use of AI in these workplaces, especially since like you have goals like sustainable development goals and like rights of Mother Earth, and so yeah, I was just wondering how to navigate those things. And then end question.
So we should be really proud of New Mexico, because if you, I'm going to put another QR code up later, but New Mexico is kind of setting the standard. These Meta and these organizations that are coming to New Mexico to set up data centers, they are making sure that it's sustainable use of the water, so that by the year, I don't have the exact facts, but by 2035 or something like that, the water will start to be, it's all recyclable and restorable. And so there are 3 data centers that are being built with these high standards. So my view is that it's just the same thing with climate change. There are solutions, but who is actually doing them, right? The people with interest to just continue with coal and continue with the traditional ways. They just want to do what's easy and fast, but it doesn't mean that it's not possible. And New Mexico, if you look it up, is really setting the standard. So it's one of the reasons why I'm doing AI in space. I mean, space too gets really a bad rap because we hear from the billionaires and we hear about, space tourism and wasteful and seemingly meaningless waste, or I wouldn't want to put it down, but it's like that's the only narrative we hear for space as well. And so why I'm doing this education program is because we need to really educate our future leaders that they're the ones that have to make a difference. They're the ones that have to demand that we do things sustainably when it comes to AI, just like in space, and it is possible.
100%. And the experience we've had was because these kids are so focused on creating solutions, and they understand Mother Earth is just not going to be around forever unless you take care of this girl, right? So, to your point, this is so important, and these kids have a different mindset, in my opinion, because they are going through climate change, even though we can't talk about it anymore, but in other words, but they are right in the epicenter of it. So protecting Earth and doing things responsibly is almost part of their DNA right now.
Another question? Oh, okay.
Thank you for the question.
Did we give you a good answer? Good, aren't you?
You're doing things that need to happen. You're doing things that need to happen, and I can only wish you all the best. I would, however, recommend something for teaching or for introducing future leaders. Get them used to negotiating, not just innovating, but integrating the innovation back into the cultures around them, because it turns out that innovators without that training have a very low probability of success.
So, to your point, the young people that we work with, they are solving challenges in their own communities. So intersecting in that sphere is built in and baked in to what they already do. But thank you for pointing that out. It's very important. Yeah, just to make something is stupid. Right. It's a waste of time. It's just a waste.
And yes, it's legal, but your life can be turned by looking at a leaf one morning with a grasshopper on it.
I want to share with you one of the innovations that was this year. A team of kids, every year there's one that blows my mind. They created a technology to locate human bodies in disaster, whether it's a flood, a collapsed building, a car accident, an earthquake, and to ascertain the status of that body remotely. That's cool.
By the way, I read patents if you need some help.
I 100% are kids, yes. We're now connected. Okay.
Colin has a question.
Just going back to artificial intelligence, the large language models. A lot of science, of course, is written in English, but a lot of it is not. How do you handle the translation?
And when I got the stats on that Meta data center for the water usage, the facility is designed to operate on 100% renewable energy and aims to be water positive by 2030. I mean, it's amazing how, the narrative just in the media is just the same old thing, but people can make a difference. So the question was say again, sorry?
On the large language models,
Oh,
of course, they're
translations.
all in English.
Yeah.
How do you handle the translation? And in particular, the phrases that different cultures use
Yeah.
don't translate very well.
Yeah, so we are using the large language model I mentioned. It's called a vertical AI agent. So we're not just going out and telling AI to do whatever it wants or just going out and searching randomly. We're using it strategically for gathering, collecting, categorizing our user-generated messages. So we're using it to help us. It sounded so similar to how astronomers use it. We have so much data. How do we make connections? Like, you saw some of those messages, right? They just fire up, right? And then, like, you'll be standing there, and you'll see another one from Stephen Goldfarb about space-time, and then you'll see another one about something else, and we can't make those connections fast enough, but we feel them, right? And so I think the AI for me is exciting because it's going to do that. It's going to just, the way it does so quickly in real time, make connections and then bring up messages that are related, that have certain things that are maybe inspire the other, or who knows, I don't even know what it's going to do. And so the languages, how they're going to be taken in is through Google. We have Google Translate built into the code. We have it right now because we travel with space messengers to different countries. You might have noticed that some of the messages were in German and some of them were in Spanish. So in the app, we just changed the language of whatever message to whatever the country is that we're in, and sometimes we leave them in their original language. So the AI can handle all the different languages. And the authenticity of the culture is in the message itself because it's written by a human. So we're still human-generated messages, just the way we are, I don't even know how to describe it, but just accessing all these messages and digging deeper into it is what we're using the AI for. And then visualizing it, in beautiful ways. So it's going to cluster and come towards you, and you'll be able to grab messages with your hands instead of typing. You'll be able to use hand gestures to, like, say, show me more of this, or, what are the connections between those topics, all with body.
I wanted to ask Julia about the cosmic web and how, could you say more? I mean, it was so beautiful the way you spoke about the ring and the cosmic web in relation to Lakota cosmology and other indigenous cosmologies, and then related to math. And I wonder if you could speak more to how we might understand the cosmic web.
That's something I think about every day in my research. And so I don't just study galaxies, I study how they grow and evolve with respect to the large scale structure. And it's because of these amazing data sets and surveys that we're able to make actual maps, because we can simulate all of these things and do all the calculations from the theory. We can predict a lot of things, and that's actually what I do a lot of as an observational astronomer, as we have theories, and from the math and from the theory, and also simulations that predict things. And we go out with our data and we try to see, is that really what's happening? Is that really what it looks like? And so it's a big circle of, it's a big feedback loop of doing that. But being able to study and image the large scale structure of the universe. When I entered this field, I had never heard of it before, actually. And so I love talking about it and showing images of it.
Oh, I just had a quick thing about, so all the cosmic web, is it like this, is that string theory? It looks stringy.
Everything's connected.
It's not string theory. It's technically relates to tidal torque theory. You can Google that when you get home, but it's how structures collapse. And there's something called the cosmic microwave background, and I don't know if anyone's ever heard of that, but
there's a piece of sculpture right there showing you.
Oh, that's amazing. I need to see that. But there's very minute temperature fluctuations in that, and it's just shortly after the Big Bang, that's an imprint, and it's all around us. And so from those tiny fluctuations in the temperature, you have the gravity starts to behave a certain way, and that's how the cosmic web arises actually over time. And so it's all connected that way.
Is there any, I don't know if I've asked this to Chaco, but is there anything about, so you go out and out and out and it gets bigger and bigger, but then you go in here and it gets smaller and smaller. Is there any idea that maybe somehow the universe curves, like it comes the infinite edge and then it comes back into some kind of neutron, whatever? Is there anything like that rumbling around?
Well, there's a lot of ideas and theories, but one thing with Agnes's installation with neutrinos, she was showing me that as it built over time, it looks like a cosmic web.
Yeah.
So it's really fascinating.
I found a lot of parallel imagery that emerged when I was taking all that 270,000 particle events, like each event was one particle streaming through, right? And its particular size, XYZ axis, where it was positioned, and its momentum. Oh, yes, sorry. I was when we were taking that data of each of the particles, and then it animated live to like 24,000 of them. It looked just like the image that I had just seen from Julia's presentation of the cosmic web. It was unbelievable with the filaments and everything, and it was not intended, and it was subatomic physics that we were visualizing of neutrino events. So the universe is amazingly wonderful, and the way things from the brain, like patterns of how our brains and neurons are, they're so similar also to the cosmic web.
I don't know if any of you know from the Hindu mythology and in the Buddhist literature the story of Indra's net, right? I see some head shaking. Do you know? Yeah. So this is now ancient text from there that Indra, the king of the gods, I guess, had a universe created. His architect created a web, and each node of the web is a jewel. In some versions it's a pearl. In each of those jewels is reflected every other part of the web, and down and down and down and down. You know, it's turtles all the way down. It's reflections all the way down. In those texts, it describes this.
Wow.
I'm a storyteller, I know this stuff.
I'm gonna
actually, Woven Skies, the title was inspired by a Maori, a writer who, science and history writer, Marston, who has a wonderful book, and I think the name is Woven Skies, and it is about that idea, yeah.
I think Julia had something to say, to respond to that.
Oh, I was just gonna say the way you described that, and I'm gonna check it out, but it reminded me of the drawing that your students did of the cosmic web, where we had a boot camp and they listened to the scientists in the morning, and then in the afternoon they drew art informed by the science, and they drew a picture that looked exactly what you're describing. So.
And I want to add to that too, thinking of August over there with holography. Didn't that make you think of holography? And I studied holography in New York in the 80s, and I think that the fact that I'm attracted to these technologies like augmented reality, people ask why did I choose augmented reality to talk about particle physics, but augmented reality is you don't see anything until you hold up your phone. It's invisible, right? Like I have a 24-foot wall in that gallery that's blank. So I had to sign it at the bottom so they know something's gonna be there. And then you have to hold up your phone, and your phone is like the detector, right? Because in particle physics, until you have a detector or a telescope or something, it's invisible to our eyes. So much, I think technology as well mirrors these ideas. And I think artists that are attracted to technology people ask why we're trying to technology, and my answer is always that there's something inherent in technology that mirrors these kinds of explorations. And when new ones come out, like AI, I'm all over it because there's something new and deeper. It's allowing us to go deeper into the universe. We just have to get over our, like who was it that said, just innovating for innovating's sake and not, and negotiate. Innovating for innovating's sake, you know, and students need to be negotiators and we need to be, you know, being aware of sustainability issues, right? But the technologies are amazing. They allow us to really go deeper.
So, our human bodies are the ultimate detector. So how do you integrate that sense of the human body into the size of the universe? How do you speak about that? Because it's, you know, I think about this all the time. And one of my favorite little analogies is the closest star to the planet being a little over 2 light years away. Let's hop into the fastest spacecraft we have, and it takes 80,000 years to get there. So this is how we feel it. How do we feel this? A problem with the phone and with data is how do we feel it? Because sometimes I feel it's not there at all. It's removed. So what can we do to create this feel in essence of, you know, this universe really that we take part, this universe that we take part in and we're involved in. And so you know, how do you explain this to kids when you're in contact, close contact?
Well, I know your work, so I have to bring it back to you. How do you do that? Because your holography is one of my first tech mediums. So like, how do you do that with? But it is, of course, I'm always asking that. I'm being facetious because we're always asking that question. Right. How do we bring the body back into it? You know, and of course, interactive silhouettes is one way, but always that technology is a barrier as well, right? It's like, how do we get past this? So VR, now we get to put our headsets on. Oh, but then you got this thing on your head, right? Oh, AR, now we don't have the headset. Oh, but you got the phone in the way, you know?
It's phone like in the way and it's still stereo, it's not three-dimensional.
Exactly. Well, I'm waiting. I'm always waiting for the next big technology. That's it. Where's the, or whatever it's going to be.
The hologram is there right now.
Well, the technology really too has a lot, but it has the plate.
Yes, it does, and no, it doesn't.
Well, you could say anything about that. I mean, holography is the same thing. I felt it when I first did it. You know, it's like, I love it, but it also has that plate. You know, and yeah, it projects, but projects only within a certain visibility. Always, any technology has that fundamental question, is it though? Is it? That is what I think human beings are always looking for through the technology. But I'm sure there's other artists in the room that.
Nancy, did you want to say something about storytelling in relation to?
Yeah, well, I think that's kind of I think young people, or it's just been my experience, maybe because I am one, are storytellers. And as you tell stories and they tell stories, that intersection in the imagination and the creativity and all of that just becomes happening. Now, how you convert that into something physical, I don't know yet, but I think AI may be one of the corridors that we can use to explore the feeling. I want to just ask you, all of you, what do you think about going to Mars? How many are in favor of going to Mars?
Humans go to Mars?
Humans going to Mars. Anybody want to go with Elon?
For the species.
What?
I don't want to go to Mars, but I don't oppose people going to Mars.
I strongly oppose people going to Mars.
Okay. Why?
Because we should be putting all of those resources and all of that brilliance into healing the planet here, just like what you said. We have the technology, we are the technology, as August said. We don't need any other technology. We can hear music, we can see the stars, we can go to Chaco. I wish every one of your kids that you're teaching could go to Chaco and experience that.
Yeah.
I realize they can. But my worry is that a lot of these things are going to end up being for rich people.
So do you know how long it takes to go to Mars?
It takes 9 months.
Year and a half.
Okay, well,
Unless it's closer.
I read today that you can wait until I was
Exactly,
reading-
it gets a little
Yes,
closer.
right.
Do you know what the biggest problem is about going to Mars, other than Elon?
There's no atmosphere there, it's too cold, you
Radiation.
can't breathe the air,
Radiation, they haven't
Yes.
solved it. And I just read that there's some sort of a element that is very dangerous to the human body on the Martian surface. So, ixnay ars may, right? Let's take care of Earth. That's my goal, yeah.
Make sure Bezos.
Well, I'm glad nobody else cares.
Kit,
though.
did you want to say something?
I was just quipping.
George again? Make sure to hold.
Oh, I've heard like in spiritual realms or whatever that it's said that telepathy or like thought is instantaneous. It doesn't even need the speed of light. It's beyond that. And I just wondered if you've encountered anything or that makes any kind of sense. And then there was something I read somewhere where they said, oh, Atlantis did exist, but the reason there's no evidence is their technology was in their body, so they didn't have cell phones and all this equipment. It was just, they didn't need it. It just was, they had evolved beyond it or something like that. And then there was something else about somebody got into a UFO or something, and there were no controllers. I don't know. I like this kind of things. I don't know if it's true.
Well, I'm a Trekkie, so I can follow all that, but I can't speak to it in the real world.
The sci-fi. Oh, Paul.
Hey, I've got a quick story about UFOs. So my youngest son's a documentary filmmaker, and this woman sent him a photo of a landscape from Gemini 11, which my husband flew, and to the left side is a very clear shot of a UFO. Except for one thing. I just came across a whole box of glass slides that Pete took on his Gemini flight. I have the exact same landscape without a UFO. So, just saying.
One of the things that occurs to me is that we produce these things, we have these ideas out of a desire. I mean, we can make many, because we have free will. We have many choices we can make. We have to ask ourselves, where does that desire come from? I mean, we don't create holograms just to create them. I mean, there's a desire to create holograms. There's a desire to create an experience that the holograms give us. And this is true for AI. And this is true for all our technology. So I think that automatically, really what I'm talking about is consciousness, that we are conscious beings, and I doubt whether, and it may be a while before we have conscious computers, but maybe when someday we are able to produce androids, they would be very able to grow something that has the computing ability of even the smallest cell in our bodies has more computing ability than any computer we have designed yet, or we can imagine designing, because it makes choices. It also reproduces itself. So I think that's where a lot of this desire to know, we have a desire to know, is coming from. That desire to know is why we do our science, why we create our art, and the art is about really experiencing what we desire to know. So, I think that's the key. I think we have to remember that, the AI computer will not do anything unless we tell it to. It doesn't have the motivation. It doesn't have the ideas. It's us that give it its ideas. It's our consciousness that it comes from.
So far. Another.
I just want to say thank you for that.
Oh, do you want to say more?
Yeah, thank you. I agree.
So I have just a random kind of word to throw in the mix here. So I taught in an art school, and we used to talk about, what I call the 10,000-year argument between painting and sculpture, which is between things and pictures of things. And so everything we've been talking about today is actually a series of representations. So I just put that word out there. Like, are we really, if we're talking about consciousness or all these other taxonomies of consciousness, et cetera, but a lot of the instrumentation is producing representations. It is not producing things. And I'm just saying, I'm just giving a shout out to representations. Because they're alive and well in the room, and we're not saying that that is what they are, but that is what they are.
But a painting is a thing too.
Yeah.
Well, paintings are really complicated. Yes, a painting is a sculpture, but the reverse is not true.
Do you all think about I'm wondering about Julia. Like, what do you think about with your colleagues? Like, how does that come into play?
That's a very interesting thing to think about. A lot of the things that we do, we can directly detect things. A lot of the things that we do, we also indirectly detect things and infer things. And even my images are not an actual 100% representation because of the instrument. It's an interpretation of the instrument.
Right.
And so that's a really interesting thing to think about.
Yes.
And it makes me think of what you had said before about how to experience everything in your body. And it just makes me think about telling people to go outside and look up. Because when I look at Andromeda, that energy is hitting my eyes and my brain, and those photons are real, and they're coming into, my eyes. And so I think that is like the best way to do that, and it's the best representation, and anyone can go outside.
Maybe that isn't a representation, because that's the phenomenon. The phenomena is perceived, right, as opposed to it being represented through instrumentation. Right?
Is a hologram a representation?
No. Tell us more.
Holograms are really interesting things because their hologram means whole message, whole writing. It stores the entire information of a subject matter. And so from any point on that hologram, you can see the whole. And that's why a lot of physicists talk about the holographic universe, is because it's recorded within the entire universe what we have here. And I've been reading a little bit about current astronomical theory lately, and it seems to be aligning more and more and more with the whole, and how
The WHO.
the whole, yes, WHO. And it's really, interesting to just think about the photon and what light is, and this information in this little square, cubic cube of light that exists in this room at this moment. How much information exists in there right now? And it's like, oh my God. It's compared to what, is in your little AI computer. The computer doesn't register at all in terms of the information that exists in this.
First, this gentleman.
Julia, a question. Which part of the sky to look in to find Andromeda? North, south, east?
So
evening?
You can download an app on your phone called Stellarium.
Thank you.
And if you just type that in there and you point the phone, it'll have an arrow and it'll tell you where to.
Thank you very much.
But it's up in the sky and it's easily visible late summer, like August, in the fall. You can see it every night.
Thank you.
If you can find the constellation Cassiopeia, it's a very simple constellation. It looks like a W. And if you just trace that a little ways off of one of the corners of the W, it's right there. You'll see a little fuzzy patch.
This this cosmic web, how do we see it? Is that radiation we see, or are those galactic clusters who are making up all those the lines? Are they galactic clusters, or is it just pure radiation, like particular frequencies, like background radiation?
So,
are you picking that up? Is that what all these wavy lines are? Just radiation coming from the background radiation, essentially?
actually, so the actual web is individual galaxies make up the web, but in between galaxies there's gas. There's hydrogen gas, and we can't always see it, especially if it's far away, if it's faint. We can't necessarily detect it. So we have actually algorithms. That one map that I put up that had the purple lines, those are filaments that are generated from an algorithm to tell us where they're at.
So it's actually matter then? It's actually galactic matter, gas, that sort of thing. And you're tracing that out in the sky and it forms that web. And between that web are all these empty spaces. I mean, space is a lot of empty spaces. I wanted to make one other remark about holograms, is that one of the things that fascinates me about holograms is that you take a three-dimensional image, a three-dimensional object, I should say, and then you're able to take all that information from 3 dimensions and put it into 2 dimensions of the plate. And that's kind of amazing.
It's still 3-dimensional. Because the thickness of the emulsion that the hologram on is, 30 photons thick. So it's still three-dimensional. Most people, that's like, part of the holographic universe theory is that they're looking at a hologram as being flat, and it's not.
It's the idea that there are 4 dimensions in space, and that it then gets all the information from that is presented to us in a 3-dimensional, or what do you call it, 3-grade, 3.
Well, yeah.
But that's what
the holograms are sort of 4-dimensional, really, because they also store time.
Yeah. Meaning 2-dimensional. The fact is that it hasn't got.
So this is such an amazing, fascinating conversation. It's such a wonderful culmination of our show. So I just want to are there any last words from our?
I wanted to respond to a question that floated around that I didn't get a chance. I think it was you, Alice, that said it. It was about how are we preparing our students, for that connection with the body and stuff. And I really want to talk about that. So I talk about a lot about how I'm interested in the technology and the science, and I have gotten closer and closer to scientists, I have to say, in my past 5-6 years, and I have to artists. And it's interesting. I love the comment about representation and the thing. But what I feel like is what I try to communicate to the students is that regardless of what's going on in the world, technology, we have to listen. We have to face it. We have to deal with it. And I want my students to be at the table, especially early on when the policies are being written. Right now, space exploration, the Outer Space Treaty needs to be revised to address technology that didn't exist when it was written in 1967, like the debris in the form of AI, as we all stated. Everybody knows all the dangers. And if these are our youth leaders, they need to be at the table and knowing what this is so that they can design it and make sure and guide its design, with Earth in mind. As Nancy was saying, that's the bottom line that we talk to them about. How do we imagine a better world here on Earth? How do we use space exploration to improve our lives here on Earth? And as part of space, which is our backyard. We bring in a space lawyer, Michelle Hanlon, who works with the United Nations, and she says to them, space is your backyard. It's part of who we are and where we come from. We come from the stars. Our scientists talk to us about how we really are made of stardust. And so to separate Earth from space is not true. And so we need to do that. And then technology is just, science has been using machine learning forever. It's just now it's out in the world and people misuse it. And so I worry sometimes about students that already come to me and they have a narrative that they have in their, they really come in and say, oh, AI is bad, AI is cheating. And I'm thinking, oh my God, but if you're not using it, if you're not learning how to use it right, and how to make sure other people are using it right, and how our governments, make sure our governments are using it right, then we're not training our youth leaders. And of course, it doesn't mean that we ignore nature. Of course, we live in New Mexico, so our students are exposed to connection with the earth as well. But I wanted to just point that out because it's one of the reasons I do what I do, is to kind of make sure that they're at the table. And I mean at the table with the UN and with these space lawyers and with NASA, and making sure they're talking to professionals and experts in the field. They're talking to scientists, and they're hearing exactly what they're seeing when they look through those telescopes. One of the things that blows their mind every time, it blew my mind too, is you see all these beautiful pictures that come out now all over the internet of like Andromeda and the sombrero and they're all beautiful colored, and then they find out that they actually are not. They're actually colored by artists, graphic representation, people who are actually putting the colors for scientists to be able to understand what is actually happening in them. And so this is important. Walking around thinking, the sky is black when it's blue, or you know what I mean, or that galaxy looks like that when it doesn't. And so I think that is a lot of what I'm trying to do in this work, is like activism in the sense of making sure they're science literate, and that they're also socially literate, and know that they have to get out there and protect our Earth from people who want to use the technology or space exploration for ways that hurt us here. I wanted to just make that statement.
I think about when we were kids, now I'm going to really date myself. There was a salesman that came to the door selling these books that knew everything. Encyclopedia Britannica, remember this? Fear factor went from 0 to Mach 7. Oh my God, these kids are going to know everything, and they're going to cheat, and they're going to use the stuff that's in there, and they're going to write their thesis, and they're going to... And when the internet from DARPA came about, oh my God, that's so scary. All of these things have good, bad, and ugly, just like humans, good, bad, and ugly. And we can use these pieces of technology. I think AI is going to help in healthcare like we can't even begin to imagine. I've already seen it in real time with a member of my family, and it helped him to be in the right place with a situation. There's bad hombres, and you gotta keep them out of your metaverse, and you gotta keep them out of your AI, and you gotta keep them out, we gotta keep them out of our competition that's in 83 countries with thousands of kids. We monitor, we take care. Safety for these young people is so important because there's no place for them to network and to be together that's safe. And so I worry much more about that than AI coming to gobble up everybody. Because I think it's an amazing tool. I've been in rooms with Sam Altman. He's very, very, very focused on ethics. And some people in the AI world aren't, but he is. So you can rest a little more peacefully tonight with that little dream.
Okay, I think we should close, and then we can have more individual conversations, but thank you to our